Okay, so carrying on directly from this point, we're going to talk about how we actually control these. So as far as these circuits go, they completely lack control. As soon as you plug them in, that cylinder's going to outstroke and be jammed in position. What we're aiming at, ultimately, what the ultimate goal of these pneumatic circuits is that we can have manual circuits where a user operates them, but that we can also have automatic circuits, so that as soon as you turn them on, they do a repetitive task. That was one of the benefits of them. That, you know, one of the videos mentioned something like reduced cycle times. The idea behind that is that if you can have an automatic circuit that responds only to itself in like a closed loop, rather than having a person pressing lots of buttons to get this complex array of cylinders to do their little dance, they'll always be the same, and you can tune it so that it's really, really fast. Okay, so in order to control these circuits, we need to introduce devices called valves, right? Let's get a look at valves then. Okay, valves. We're going to, ultimately, we're probably going to look at something like 3 or 4 different types of valve, but there's 2 really, really important ones. Okay, so the first, and they've got weird names, right, but I'll explain the naming convention to you. What I want you to think of valves as being like switches. I mean, in between this, or in the single acting cylinder, in between this main air and the cylinder, we really want to have a switch, the same way you would have in electronics, where a user can press it to outstroke it, and then if they don't press it, it goes back in. And again, you can have all sorts of different, we call them actuators in pneumatics, so you can have like latching switches and non-latching switches, and you can have switches that detect linear motion and stuff. And you can have electronic actuators on there as well, but we'll get to the actuators in a minute. But the point is, we want to have a switch, and that's what a valve is. A valve is essentially a pneumatic switch. Okay, so let's look at the first valve. So the first valve is called a 3-2 valve. Told you the names were weird. So it's called a 3-2 valve because it's got 3 ports and 2 connections. 3 ports and 2 states. So you need to be able to draw this. It's drawn as the 2 states, like the on state and the off state. So we start off with a rectangle and we divide that in 2. So what I'm going to do is the top state is going to be the on state, and the bottom half of this is going to be the off state. So as I said, there's 3 ports on it. The ports are always drawn on one of the 2 states. Okay, so you wouldn't have like 2 ports here and 1 port up here. The 3 ports of the 3-2 valve are always drawn in the same state. All 3 could be drawn in that one if you wanted. It wouldn't be wrong if the 3 ports appear at the top half, or if the 3 ports appear in the bottom half. Just don't mix that up, right? And then the internal, so we would think of this as being the input port, this is the output port, this is the exhaust port. In the off state, the input port shouldn't be connected to anything, and the output port will be connected to the input port for the purposes of exhaust. So we would do that with an arrowhead on it. Alright. And then what we do is we imagine that the 3 ports are up here. Yeah, we imagine it's almost as if this thing has slid down. In fact, you know what? I think I could do that if I get rid of the ports off there just now. And select that and group it. And put ports back away. 1, 2, 3. Yeah, fantastic. Move that out the road. And group those 3 ports. Say this back. Right, okay, so you imagine it being like that when it's on, and it's sliding down to that when it's off. Okay, that's how this symbol works, right? I get to cheat and do this. You guys can't. There you go. And it looks like that when it's on, and the exhaust port isn't connected to anything. So that's a 3-2 valve. Okay. In fact, we just group that whole thing. You need to be able to draw that, and it's okay if when you draw this symbol, it's okay if you reverse it or if you draw it upside down or draw it on its side, that's fine, as long as it makes sense internally, as long as that output port is connected to the exhaust port on the off stroke, on the actuator in the off state, and the input port's teed off, and then vice versa. As long as the two states are correct and the three ports appear on the same state, that's all that matters. So you can draw that, you can draw that, or you can draw it reversed, upside down, on its side, whatever, as long as everything makes sense. That's a 3-2 valve, so called because it has 3 ports, 1, 2, 3, and 2 states, 1, 2, and the 2 states are off and on. In real life, the exhaust port on the 3-2 valves that we use doesn't tend to be there again, it just tends to be a hole, because all that's coming out of that is a little puff of exhaust air every now and again. So, how, this is then the question, how do we make the 3-2 valve go from there to there? How do we get it to change state? The way we get it to change state is that we have 3-2 valves with different actuators on them, and again, a lot of symbols. Okay, so let's get a look at actuators. I'm going to draw the symbol and say the name. I'd expect you to draw the symbol and write the name next to it. Okay, so you've got a push button. It's interesting to see if I can remember them all. A spring. You've got a plunger. So a plunger is a thing that detects linear motion, something striking it essentially. You've got a roller. So the roller detects passing motion, so linear motion but going across the way instead of straight in. You've got a roller trip, which is 2 wee wheels, so this one out to the right hand side kind of flops up and down, and again it detects passing motion, but it detects passing motion of something large. It's got a lot of displacement in it. What else you got? You've got a solenoid. We should recognise a solenoid from electronics. So solenoid is just that electrical device, so we can use electronic symbols to make these electronic signals to make this change state. We've also got, and this is another important one, maybe not so much for 3-2 valves, but later on, we've got pilot air, where that triangle will be pointing into the valve. So that pilot air is another air signal that goes from a valve to another valve. In industry, that would be a lower pressure. In the circuits that we build, it's just the same pressure as in here. And you've got another one that looks like this. This is called a diaphragm. And we'll come back to diaphragms later on. But diaphragms are essentially really, really fine, thin, elastic membranes, like the skin of a balloon, and they respond to very small changes in air pressure. So we can use diaphragms, we can use wee tiny air leaks called air bleeds to detect or to trigger valves. The plunger, the roller and the roller trip, these three that I'm just grouping just now, they are the ones that allow automatic circuits to operate as well as solenoids, obviously. We've also got foot pedal and lever. What's that? 1, 2, 3, 4, 8, 9, 10. I think that's them all. So these are, again, they're in the notes, right? But these are the ones that are based on kind of manual operation. With the spring is used for non-latching or momentary signals, and then these guys are the ones that allow for that automatic operation, and these two are kind of a mixture of that. because you can use them to detect either automatic signals or manual signals. Okay, so solenoid, roller trip, plunger, roller, pilot, diaphragm, foot pedal, lever, push button and spring. Okay, so those are our actuators. I'd expect you to take copious notes on that so that you know what they all are and what they're for. I've said it all, you can rewatch this video to get all that information written down. So how do we use actuators with a valve? You know, what does it look like when we draw it? So if we were drawing a proper valve, we would draw the valve and then we would add whatever actuator it is that switches on, and importantly whatever actuator it is that switches it off. Okay, so the most common 3-2 valve is a push button, spring return. That's the most common 3-2 valve. So the expectation is that you would know that the name of that valve is pen stops working. The name of that valve is a push button, spring return, 3-2 valve. So notice it's named for the actuator on the top, the actuator on the bottom and the valve type. Push button, spring return, 3-2 valve. So what I'm going to ask you to do is I'm going to ask you guys to name a bunch of valves, and then I'm going to ask you guys to draw a bunch of valves based on the name. Okay, so go ahead and do these. Name this valve, name this valve, name this valve, name this valve, and then draw these 4 as well, really carefully. By the time you get here, you should have already drawn them though. Right, okay, so we'll call it quits for this video now. Thank you very much.